In the polar coordinate system, we specify the position of a point relative to a pole, which is just a point that we've chosen in the plane, and a polar axis. The polar axis is often identified with the positive x-axis, the pole with the origin of an xy coordinate system. But it doesn't have to be part of an xy coordinate system. It's a system in itself. We simply have a point and an axis here that specifies a direction. All that's important about this axis is a direction. We don't worry about distances along this axis. Now, to specify the coordinates of a point, we specify the point by the distance r, or the displacement r from the pole, and the angle theta in which that displacement takes place. So if we've got a point here, it lies at some displacement r from the pole along some angle theta measured relative to the polar axis. And r and theta are then the polar coordinates of that point. We think of this as, I'm going to call this our radial line, moving out from the pole radially. We had a bunch of these lines, they'd be moving out radially from a center, as in a circle or something. Okay, now, for an exercise, before you go on to the next part of the clip, you should go ahead and sketch these points. Okay, this is what we did in class. We took a few minutes and sketched these points, then we looked at the sketch and discussed it. So you should pause at this point and sketch these points. Don't look at the solution before you've done the problem. Okay. Now here are two of the points. Here's our pole, here's our polar axis, and the point 3 pi over 6 comes out in the direction pi over 6 with respect to the polar axis. That's a lot like coming out at a direction pi over 6 with respect to the x-axis at an angle of pi over 6. We come out a distance 3 along that segment. So coming out a distance 3 along direction pi over 6, this is what we get. To get to point 5, 2 pi over 3, we come out in the direction of the ray at angle 2 pi over 3 with respect to the polar axis. Here's the angle. And we come out a distance 5. So this one will be at this angle and a little further than the 3 here. Okay? Actually, it should be a little further according to scale. My scale isn't real good here. Now, let's think about the point negative 3 pi over 4. You might have wondered what to do with that negative. Now, this is supposed to be a straight line here. It's not all that straight. If we come out pi over 4, and if we were to go 3 units, of course, we'd come out 3 units in this direction. Okay, now remember I said that r was the displacement, not the distance from the pole. Okay? I might occasionally slip up and say distance, but it's really displacement. And displacement has a direction. So if a displacement of 3 brings us out to here, then a displacement of negative 3 is going to have to bring us out in the opposite direction to here. So here's our negative displacement. And here's our point, negative 3 pi over 4. I didn't label the point as I did with the other 2 points here. But if I did, it would be negative 3 comma pi over 4 in parentheses. A more global way of seeing what's going on is to sketch a figure like the one you see. This isn't very well drawn. It's kind of difficult to draw concentric circles. I can draw a single circle fairly well, but when I get into concentric circles, I'm not that good at it. These are supposed to represent concentric circles centered at the pole. Here's the pole. And here's our polar axis, the one with an arrow on it. That's our polar axis. So, first circle would be at radius 1, second radius 2, the third would be radius 3, radius 4, radius 5. Or distance 1, 2, 3, 4, and 5 from the center. Okay, so any point on this circle, let's say, lies at r equals 4, or possibly r equals -4 from the pole. Then we sketch the angles from pi over 6 all the way around to 2 pi in multiples of pi over 6. We could have thrown in the multiples of pi over 4. We might have just used the multiples of pi over 4. But this is kind of a polar. Well, this is a representation of a polar grid. Just like in rectangular coordinates, we have a rectangular grid, just little squares marked across the plane. When we're in polar coordinates, we have these circles to represent the different values of r, and these radial segments here to represent the different values of theta. Then we can easily locate the point 3 pi over 6. It's on the circle of radius 3 and at angle pi over 6. So there it is. 5, 2 pi over 3, well, it's on the line where we got 2 pi over 3 out here at radius 5, distance 5 from the center. Now the -3 pi over 4, which you see labeled down here, we'd come out at the angle pi over 4, which would be halfway between the pi over 6 and pi over 3 in about this direction here. Trying to do that so you can see it, but about that direction. But we're going to go in the opposite direction because of the -3. If we did a displacement of 3, as we've said, we would end up at about this point. Going to displacement -3, we end up at this point.